All right. First of all, we're going to learn how to tell if two samples are dependent or independent. This chapter is about comparing two means. In chapter 7, you learned how to test one mean. Now we're going to compare two means. For example, if someone claims that women spend more time online shopping than men. Now this is involved, two groups, groups of women and groups of men. We're going to learn how to test the hypotheses and comparing two means. Or if someone says the proportion of women who seek a nursing major is more than the proportion of men who seek a nursing major. This is comparing two sets, again, women and men. So this is what we're going to learn in this chapter, comparing two means or two proportion with two samples, whereas in chapter 7, it was only one sample. So this is the main difference between chapter 7 and 8. So independent samples. The sample selected from one population is not related to the sample selected from the second population. That's the definition of independent samples. Dependent samples, they are called paired or matched samples. Each member of one sample is related to a member in the second sample. And here's an example, guys. Watch right here. You can see the first two samples have nothing to do with each other. They're not related at all. Actually, this sample has 4 members, and this sample has 1, 2, 3, 4, 5, 6, 7 members. So, and there is no relationship. This is an example of independent samples. Well, look here. There's sample 1, sample 2, and you see the relationship. This member right here is related to that member. This member is related to this one. That one is related to this member in the second set, and so on. So this is an example of dependent samples. Let's give you some more examples. What do you think of this example right here? Classify the pair of samples as independent or dependent. Weights of 65 college students before their freshman year begins. Weights of the same 65 college students after their freshman year. What do you guys think? Dependent or independent?
Independent.
Actually, we're doing the weight of the same students before the freshman year and after the freshman year. They are dependent. So when it is about the same group, the samples will be dependent. Because if you try to do a diagram, it's going to be student 1 before and student 1 after. Student 2, what was the weight before and what was the weight after, and so on and so forth. So they will be related to each other. These are dependent samples. If it is about different groups, then they will be independent. So let's look at the second one. Scores of 38 adult males on a psychological screening test for attention deficit hyperactivity disorder. Scores of 50 adult females on a psychological screening test for attention deficit hyperactivity disorder. What do you think right now, guys? 38 males, 50 different females. So they're totally two different groups. In this case, you can say that they are independent. And if you were asked why, you just say the first group has 38 adult males. The second group has 50 adult females. They have nothing to do with each other. It's not the same group. It has to be, guys, the same group before and after. Here, it's a different group. It's a group of adult males and group of adult females. Any questions here? Okay, let's go to the next page. how we're going to state the null and the alternative hypothesis when we compare two mean. Okay, the null hypothesis is a statistical hypothesis that uses that usually state that there is no difference between the parameters of two population, and it always contains less than or equal to, or greater than. The alternative hypothesis is a statistical hypothesis that is true when the null hypothesis is false, and it contains a greater than, different from, or less than. When you compare two means, guys, in chapter 7, when we compare the mean, we use this sign mu. But because we are comparing two population means, we have to have a mu1 and a mu2. Mu1 represents a population 1, and mu2 represents a population 2. So instead of one mean, we're going to have a mu1 and mu2. And look how we're going to state the null and the alternative hypothesis, guys. Either mu1 equals mu2 in the null hypothesis, then you can see what the alternative will be. Mu1 is different from mu2. Or if you have a mu1 less than or equal to mu2, then mu1 is greater than mu2. That would be another scenario. And that is the third scenario. So when you do a problem in this section, guys, you only select one of those three as your null and the alternative hypothesis. There are no numbers to use, on the right-hand side, like testing the mean, testing the claim that the mean is more than 50. No, here it's going to be test that mu1 is bigger than mu2, or test that mu1 is less than mu2, or test that mu1 equals to mu2. So this is how it's going to be like. So you always select one of those three. So actually, in another way, it's easier, than the previous chapter, because you don't have to worry about numbers. You just select, just one of those three statements for your null and the alternative hypothesis. And in any hypothesis test, we always assume that the null hypothesis is true until proven otherwise. So we always assume that mu1 equals mu2 unless proven otherwise later, unless if we reject HO. Here's the section 8.1. We're going to do a two-sample z-test to test the difference between two population means when sigma 1 and sigma 2 are known. In your section 7.2, guys, it was sigma is known. Now we have two population standard deviations are known. What are the conditions to perform this test? 4 conditions are necessary to perform a z-test for the difference between two population means. Population standard deviations are known. The samples are randomly selected. You always have to have randomly selected samples. The samples are independent. I explained to you what independent samples mean. And the population are normally distributed, or the size of the sample is at least 30. So either he has to tell you that the population are bell-shaped, or he has to give you a sample size that is at least 30. How to perform the test? First of all, verify that sigma 1 and sigma 2 are known. Verify that the samples are random and independent, and verify that the population is normally distributed or the sample sizes are more than 30. This is how to verify the test. And look at the condition of that, how to do the test, guys. It's the same thing as we did in chapter 7. That's what I meant earlier. State HO and HA, calculate the test statistic Z, calculate the p-value, make a decision to reject or fail to reject the null hypothesis, interpret the decision in the context of the original claim. And I'm ready, guys, to show you how to work out those problems. So we're going to do a couple examples together. Notice 12 students are absent today. That's nice. And it's a bit disappointed, just when some students don't do well on the test, and yet they decide that they don't need to attend. Just a reminder, guys, that the attendance will be used to determine whether students will pass the 041 course, the support course, or not. So if you have been attending class, please continue to do so, because I do take attendance every time I meet with you. All right, this example. A credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. If I want to state, guys, the null and the alternative hypothesis, would you be able to do it based on the first sentence? A credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. So we have two groups, households in California and household in Illinois. Which pair, guys, would you use? First, second, or third? Any response? It says there is a difference.
The first one.
The first one, exactly, because this is where the difference is. So we will write that down later. The results of a random survey of 250 households from each state are shown at the bottom right here. The two samples are independent. Assume that sigma 1 is 1045. So he gives you sigma 1 and sigma 2. Once he gives you sigma 1 and sigma 2, guys, it's a z-test. Do the results support the group's claim? Use a 5% level of significance. Are the conditions of the test met? Yes. Why? Let me tell you why. Let's check. The population standard deviation are known. Sigma 1 and sigma 2 are known. That's the first condition. The second condition, the samples are randomly selected. Look, guys, he says the results of a random survey. So the surveys are random. You wouldn't be able to do the test if the conditions are not met anyway. And the samples are independent. The two samples are independent, he says right here, guys. So independent samples. And then you must have population that are bell-shaped or sample size more than 30. We'll look at the sample size here. It's 250 and 250, so the sample size are more than 30. So we can go ahead and perform the test. Okay, so we have X1 bar is 4,777, N1 is 250, X2 bar, you see you have a sample mean from sample 1 and you have a sample mean from sample 2 now because you're doing two sets, not one set anymore. And X2 bar is 4,866, N2 is 250. Okay, let's go to the next page and put in some details. Step 1. So step 1, guys, H1, HO, and H1. Mu1 equals mu2. And HA will be mu1 not equal to mu2. Let's see where the claim is. Let me read this again. A credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. So this is where the claim is. All right. And now I think we can go to the calculator and show you how to perform the test using your calculator. It's very easy test once you know how to input the data. So I'm gonna grab my calculator. And if you can get your calculator, guys, and perform the test together. Okay, here's the calculator. I'll use this one today. So you go to stat, tests, and you can see it, guys. It's number 3, two sample z-test. Okay. Sigma 1. What was sigma 1 in the exercise? There you go. Sigma 1 was 1045 and sigma 2 was 1350. So I'll enter this. Now he's asking you for X1 bar. X1 bar is 4,777. Then N1, which is 250. X2 bar, you can see it right here. It's 4,866. And 250. Now the last step, guys, before you hit calculate, you have to choose the alternative hypothesis sign, which is not equal to. So I'm going to select that one. And that's it. Calculate. So Z is negative 0.82 and the p-value is 0.4098. Let me write them down. .4098. Okay, that's all we need. It's just like in the previous chapter. Once you have the p-value, he says test at the 5%. So alpha is 5%. P-value, you agree with me, it's bigger than alpha. Fail to reject. HO. And what is the conclusion? The claim is in H1, HA, so there is not. Remember, when you fail to reject HO, you start with there is not enough evidence at the 5% level of significance. 2, since the claim is in HA, we say the word support. To support the claim by who made the claim? The credit card watchdog group. So we're saying we cannot support this claim. There is not enough evidence to support the claim. You can see, guys, it's just whatever we did earlier in the earlier chapter, we're just doing the same thing, but instead of working with one sample, we're working with 2 samples. That's a big difference in this chapter. Any questions?
I have one. If the claim was in HA, what would you say?
It is in HA.
My bad, HO.
Oh, you would say, let's say the claim was here, okay? There's what you say, and you fail to reject HO. So you say, there is not enough evidence at the 5% level of significance to reject the claim. So if the claim is in HO, you use the word reject right here. And if the claim is in HA, you use the word support. And if you fail to reject HO, you start with there is not. And if you reject HO, you start with there is enough evidence. That's a big difference. And the word reject and support, they're opposite of each other. So they mean, just totally something different, when you put either word. So it's very important. So if the claim was here, guys, and you did not reject HO, you say there is not enough evidence to reject the claim, it means you probably accept the claim. You will accept the claim. So it's a big difference between the two. Any questions? Let's go to the next one. A travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. So Texas is labeled as number 1 and Virginia is labeled as number 2. And they claim that the cost of vacationing in Texas is less than that of Virginia. Let me show you guys the three scenarios and tell me which one would you choose. First, second, or third? No answer? Doesn't seem like anyone is with me.
Can you repeat it? I didn't really hear it.
You guys, you have to pay attention to this, please.
The third one.
I'm saying they claim that the cost of vacationing in Texas is less than the cost of vacationing in Virginia. That's the claim. And Texas is labeled as a mu1 and Virginia is labeled as a mu2. So if you are to pick the set of the hypotheses, which one would you pick?
The third one.
Third one.
Does everyone agree it's the third one? Because mu1 is Texas and mu2 is Virginia. And he wants us to test that Texas is less than Virginia. That is correct, guys. It's the third one here. This is how easy it is. I'm trying to show you, actually, it's easier than figuring out the null and the alternative hypothesis in chapter 7, because you just pick one of the three. So that is correct. So I'll write it down. And this is the claim. This is mu1. This is mu2. I didn't label Texas mu1 myself. It isn't the problem. You see, he says 1 here and 2 there. So we don't have a choice. This is how they are labeled. The table below shows the results of a random survey of vacationers in each state. The two samples are independent. Assume that sigma 1 is $19 for Texas and sigma 2 is $24 for Virginia, and that both populations are normally distributed. At alpha equals 1%, is there enough evidence to support the claim? So can we support the claim? Okay, let's do this together, guys. Let's verify if the requirements of the test are met. Are the samples randomly selected? Yes, it is a random selection. Are the population standard deviation known? Yes, sigma 1 and sigma 2 are given. Are the samples independent? Well, he says they are independent right here. Are the sample size more than 30 or the population are normally distributed? Well, he says assume that the population are normally distributed. So the sample size are not more than 30, but he says that the population are bell-shaped. So we meet the requirements of the test, and it is a two-sample z-test, guys. So I'm gonna put here a note. Use two-sample z-test when sigma 1, sigma 2 are known. And they are known here. This one and this one right there. Okay, let's do this. Grab your calculator, guys. And let's do this. So we're gonna go to stat, tests, two sample z test, and watch. Shouldn't be a bad section at all, guys. It shouldn't be difficult at all to learn this section. Okay, sigma 1 is 19. Sigma 2 is 24. X1 bar 234. So I'm copying from here now. N1 is 25. X2 bar 240. N2 is 20. And we need to check that mu1 is less than mu2. All right. And now we're gonna hit calculate. And here you go. Z is negative 0.91. I hope everybody got the same thing. And the p-value, as you can see, I got, for the p-value, I got 0.1808. which is definitely more than alpha. Fail to reject H. All right. Here's how you begin. You start with there is not, because fail, you do not. Enough evidence at the 1% level of significance. To what, guys? Since the claim is in HA, what's the word here?
Support.
Support, exactly. There is not enough evidence to support. We're saying, it's not that we're saying we're supporting, we're saying we're not supporting because the word not here. There is not enough evidence at the 1% level of significance to support the claim that average, I'm gonna write it down just right here, cost of meals and lodging for vacationing in Texas is less than that of Virginia. All right, so that is section 8.1, guys. We conclude this section. I will do another exercise later, but there is the section. You use a two-sample z-test when sigma 1, sigma 2 are known, and when you're testing the difference between two means, mu1 and mu2, where the samples are independent. So here's my summary here. I would like you guys, if you have like a yellow marker, to highlight the summary, because that tells you what to do when you see a problem from this section. Perform a two-sample z-test for the difference between two means, mu1 and mu2, with independent samples with sigma 1 and sigma 2 are known. That is my summary for this section. All right. Now I'm going to go to the second section and show you how to work problems in there. Okay, let me show you the difference between the two sections. Testing the difference between means, independent samples, sigma 1 and sigma 2 are unknown. In section 7.2, guys, we tested the mean when sigma is known, and in section 7.3, we tested the mean when sigma is not known. It's the same thing here, but instead of one means, we're doing two means. Instead of using a two-sample z-test, it's going to be a two-sample t-test. And same thing in the previous chapter, guys. Instead of using a z-test, you use a t-test. So the only difference is two sample instead of one sample. What are the conditions of the test? Sigma 1 and sigma 2 are unknown. The samples are random. The samples are independent. And the population are normally distributed, or the sample size must be greater than 30. So it's the same conditions that you have to meet, just like the previous sections. Okay, before we proceed, guys, can you, we're gonna state the hypothesis, difference between two means, same hypothesis as in previous sections. So you have this scenario, you either could have this. That's one scenario. And same thing, just copy and paste what we did before. You could have a mu1 less than or equal to mu2, and then mu1 is bigger than mu2. You just select one of them. Or you could have mu1 is greater than or equal to mu2. Mu1 is less than mu2. Same thing. Two sample t-tests for the difference between two means, small independent samples. First of all, verify that sigma 1 and sigma 2 are not known, because if they are known, you have to go to the previous section and use two sample z-test. Verify that the samples are random and independent, and either the populations are normally distributed or N1 is greater than 30. Now we don't use 1N, guys, because we have two samples. So we label them as 1 and 2, N1 and N2. Same thing as the previous section, state HO and HA, calculate the test statistic, but look, I don't call it Z now, I call it T. Even your calculator is gonna call it T now. Calculate the p-value, make a decision to reject or fail to reject HO, interpret the decision in the context of the original claim. And we'll come to this in a second here when we perform the test. Okay, let's do an exercise. I'll go slow with this one, guys, because I like you not just to do it with me. So please, if you have a scrap piece of paper, just let's do this together. The results of a state mathematics test for random sample of students taught by two different teachers at the same school are shown below. So this is teacher one. Shouldn't be a $sign here. And teacher two. Can you conclude that there is a difference in the mean mathematics test score for the students of the two teachers? Use alpha equals 10%. Assume that the population are normally distributed and that the population variances are not equal. I'll come to this in a second. Okay, guys, can you tell me first of all which set we're gonna use, first, second, or third? He says, can you conclude that there is a difference in the mean mathematics test scores between the two teachers?
First.
First one.
I agree. It is a first one, guys. This is very important to be able to pick the correct null and the alternative hypothesis, because if you don't, you will be testing a totally wrong claim. And the difference means here. If he asks you, can you conclude that they are equal, then your claim would have been in the null hypothesis. So the claim is in the alternative. And remember, guys, when you write your final statement, you have to use the word support, not reject, because the claim happened to be in HA. Okay, let's see if we can verify that the requirements of the test are met. Are the samples random? Well, he says they are random. Are they independent? Yes, they are independent because they're two different teachers, two different groups of students. So they are independent group of students. Are sigma 1 and sigma 2 unknown? Yes, they are unknown. He didn't give me sigma 1, sigma 2, but he gave me instead, guys, S1 and S2. Are the population normally distributed? Well, he says, assume that the population are normally distributed. So the requirements of the test are met. In this case, guys, if he doesn't give you sigma 1 and sigma 2, you have to use what we call two-sample t-test. Okay. And let's go to that and show you how that works. All right, let me show you. So go to stat tests. Stat tests. And look, guys, it's number 4. So it's they're mainly all on the main screen here. The first screen is all reserved for chapter 8. So two-sample t-test. Okay. He wants you to enter x1 bar. Well, x1 bar, it's given right here, 473. It's a test score, so I put by mistake a $sign, guys. S1, 39.7. N1 is 8. X2 bar is 459. S2 is 24.5. N2 is 18. You see two different sample size, so that means they're independent. They have nothing to do with each other. Okay, now pick the alternative sign. The alternative sign, guys, is different from, so I'm gonna pick that one. There's one more. Okay, pooled. No or yes. Let me explain this to you guys, and then you would know what to do after I explain it. If he tells you in the problem, assume that the population variances, we learned about variances in chapter 2. Variance is the square of the standard deviation of the population. If he says the population variances are equal, then you use yes for pooled. And if he says the population variances are not equal, then you use no for pooled. And so I'm gonna go back here, guys. Select the pooled yes if the population variances are equal, and select the pooled no if the population variances are not equal. And here they write it, sometimes they, instead of writing saying population variances are equal, they write this in the problem statement, or they write that not equal, because the population variance is called sigma square. So since I have two population variances, we label them as sigma 1 squared and sigma 2 squared. So given what I said, guys, and he says variances are not equal, we have to select no here. So make sure to select, press enter. And if you try later to do a yes, you're gonna get different answers. So just be very careful with that, and then hit calculate. All right, so I got T to be 0.9. If you get different answers, let me know. You should get exactly the same thing, unless if I made a mistake. And the p-value, guys, is 0.3792. All right. Which is, you agree with me, it's more than alpha. And then you fail to reject HO. This is what I meant by no in chapter 7. I'm just doing now, I'm back to chapter 7, same interpretation as we do in chapter 7. If you fail to reject a null hypothesis, you start with there is not. I'll capitalize this. Enough evidence at the 10% level of significance to support the claim. So we're saying we cannot support the claim. So probably the claim is not correct. We're saying there is not enough evidence to support the claim that there is a difference in the mean math test scores between the two teachers. All right, guys, any questions about this? I mean, probably you look at the X1 bar and X2 bar and you see that they are different, the sample means. So why don't we have a difference? The thing is, probably the difference is not that significant, guys. So that's why. Like for someone who have like, they say, you know, just if your total cholesterol is above 200, it's considered high. If someone has 202 and someone has 205 number, if you want to test that those numbers, you know, they're totally two different cholesterol levels, you might be able not to support that, because 202 and 205 are pretty much, you know, just the same. And here it turns out, you know, just to be the case here, that the difference is not substantial. That's why we could not support the claim that there is a difference in the mean scores between the two teachers. Okay, we're gonna go to another problem. All right, let's do this one together. Manufacturer claims that the colon range in feet of its 2.4 gigahertz cordless telephone is greater than that of its leading competitor. So they claim that their calling range is greater than their competitor. You perform a study using 14 randomly selected phones from the manufacturer and 16 randomly selected similar phones from the competitor. So we're gonna just do this right here. This is the manufacturer, and this is the competitor. Okay, so write down the X1 bar, guys, and X2 bar, S1, S2, N1, N2. Now, I label the manufacturer as number one because he started talking about the manufacturer first. So what is N1? He says 14 randomly selected from the manufacturer and 16 from the competitor. Okay. The results from the manufacturer have a sample mean of 230 with a standard deviation of 26. He didn't say population standard deviation, so don't make it sigma, guys. It's S. And the results from the competitor have a sample mean of 216 with a standard deviation of 32. At alpha equals 0.05. Can you support the manufacturer claim? So let me show you guys. So the manufacturer claimed that their calling range is higher, greater than that of their competitor. Can you tell me, guys, which one is it gonna be? First, second, or third?
Second.
Second.
I do agree. It is the second because we're trying to claim, to study the claim that the manufacturer is higher than the competitor. It's right here. Greater. Greater means this sign right here, guys. So you are correct. It is the second one. You see, guys, you don't need to invent anything to figure out the null and the alternative. Just put the three scenarios in front of you and pick one of them. That's it. So I'll put this here. This is mu1 and this is mu2. To figure it out, here is another way to figure it out. He says, claims that their calling range is greater than that of the leading competitor. So greater, just put the sign here, greater. Put it in the middle, guys, and look, you see mu1 is greater than mu2. Go here and look, where is mu1 is greater than mu2? You see it right here. Then your null hypothesis will be the total opposite right there. So that's another way to figure it out. H1, mu1 is greater than mu2. Mu1 is greater or less mu2, and that's the claim. All right. Two sample t-test. All the requirements of the test are met. Let's do it. Clear, stat, and tests. Two sample t-test. Okay, X1 bar, 230. S1, 26. Please, guys, try to do it with me. That's the best way to learn, not just watching me doing the stuff, because I know when you watch me doing the stuff, it might make sense to you, but the challenge is to go back and just do it on your own. S2 is 32, N2 is 16. Here you go. For some reason, the screen share, okay. Can you guys see my screen now?
Yeah.
Okay, thank you. And what else do we have? Let me just zoom in a little bit more. All right. So we got S1, N1, X2 bar, S2, N2, different. So we need to check that mu1 is greater than mu2, right here. And pooled. Okay, based on what you learned about pooled, guys, what do you think? Assume that the population are normally distributed and population variances are equal. So what do I use for pooled now?
Yes.
Yes, very good. Let's do a draw this time. So I get T to be 1.303 and p-value 0.1017. So if I want to do 3 decimal places, 0.3. We haven't rejected the null hypothesis today yet because the p-value always turned out to be bigger than alpha, which is okay, 1017. And my alpha is 0.05, which is bigger than alpha. I didn't intend for the problems to turn out like that, but it did happen. So fail to reject HO. There is not. Enough evidence at the 5% level of significance to, what's the magic word, guys? The claim is in HA.
Support.
Support the claim by the manufacturer. All right, so we say we don't have enough evidence to support the claim by the manufacturer that their calling range is higher than the calling range, just of their competitors. So probably their claim is wrong. So in summary, perform a 2-sample t-test for the difference between two means, mu1 and mu2, with independent samples with sigma 1 and sigma 2 unknown, not known. And perform a 2-sample z-test for the difference between two means, sigma 1, mu1 and mu2, with independent samples with sigma 1 and sigma 2 known. So that's the difference between z-test and t-test. And this is the most important thing, guys, to know which test to use. I know students know that they have to go to 2-sample, because if you look at the screen here, guys, students know, they see a 2-sample z-test and 2-sample t-test. But I don't want you to jump, just to a sample z-test once you see mu1 and mu2. It will be 2-sample z-test if he gives you sigma 1 and sigma 2, but it will be a 2-sample t-test if he gives you S1 and S2 instead. So there is a big difference between S and sigma. What I'm going to do now, I'm going to do some practice exercises on this. So I'm going to flip through the pages. All right, no test, just one second. Let me pause the recording for 1 second. At a local college, 75 male students were randomly selected, and their mean monthly income was found to be $654 with a standard deviation of 168. All right. 65 female students were also randomly selected. It was found that their monthly income was $612 with I'm going to add the word population standard deviation of 121.50. Test the claim that male students have a higher monthly income than female students. So I'd like you to just add here the word population. Population standard deviation. Test the claim that male students have higher in monthly income than female students. Okay, so we have two sets, guys, male students and female students. Let's label them. Male, label them as mu1, female as mu2. Okay, let's see what kind of data we have here. You see, in chapter 7, we'll just put X bar. Now we have to do X1 bar and X2 bar because we have two sample means. Okay, what is X1 bar for male students? It is 654. What is sigma 1? Now I changed it to sigma 1. It was going to be S1, but 168.70. And what is N1, guys? He says 75 male students, so N1 is 75. X2 bar. Now let's go to female students. 65 female students were also randomly selected. It was found that their mean monthly income was 612. Sigma 2.
Wait, why is it sigma when it's giving us S?
Oh no, I said, but I changed the wording.
Okay.
I made a mistake. I didn't put the wording in here.
Okay.
That's a good question. And N2 is, what is N2? 65. However, guys, just for your information, but I want you to follow the same patterns, you know, that you've been used to do. If sigma is given, you use Z. If sigma is not given, you use T. However, the T distribution will be very much like the Z distribution when the sample size is more than 30. So it will be pretty much the same results. But I would like you to stick to the fact that if sigma is given, use Z. If sigma is not given, use T. Okay. We need to test the hypothesis. Do you guys agree that we need to test that male students have higher monthly income than female students means mu1 is greater than mu2? And it's right there. mu1 is greater than mu2. And let's test the claim at 0.01. Okay, so you should agree with me. It's a two sample Z test, and we're going to do it together, and we're going to get the same results, guys. But I want you to practice doing this. Sigma 1, 168.70. Just make it closer. Sigma 2. Sigma 2 is right there, 121.50. X1 bar, 654. N1 is 75. X2 bar is 612. N2 is 65. And we want to check that mu1 is bigger than mu2. Make sure to select it and press enter, guys. If you don't press enter, it's not going to be selected. Sorry, this one. Let's just keep the screen for a second. Make sure. All right, and then we're going to go to calculate. So Z is 1.705, 1.71, and p-value is 0.0441. And let's see. 1.71, that's the tested statistic Z. and the p-value, which is 0.0441, which is more than alpha, we fail to reject. So I'm gonna write it down one more time. P-value is more than alpha, which is 0.05, as a 1, sorry. So fail to reject HO. And your conclusion, guys, will be there is not enough evidence at the 1% level of significance to support the claim. All right. So this is how you work out two sample z-test when sigma 1 and sigma 2 are known. And if you go back and you need some more support with the calculator, guys, I provided the screenshots of the calculator. Now we're gonna go and do another problem from section 8.2. Okay. And that's a good one because we have to enter data in it. A sports analyst claims that the mean batting average for teams in the American League is not equal to the mean batting average for teams in the National League because a pitcher does not bat in the American League. The data listed below are from randomly selected teams in both leagues. At alpha equals 5%, test the sports analyst's claim. Assume that the population variances are equal. Here is a hint for you guys. Once he says assume population variances are equal or not equal, you know it's two sample t-test because this is the only test that has this feature right there. So before we do anything, I would like you to put American League data in L1 and National League data in L2. And I will do the same. So I'll pause the recording for a second. So this is MU1 and this is MU2. And you guys, he says, a sports analyst claimed that the mean batting average for teams in the American League is not equal to the mean batting average in the for teams in the National League. So it's clear that he wants us to test that mu1 is not equal to mu2. That's the claim. It is a two sample t-test. And if you ask me why, because he didn't give me sigma 1 and sigma 2, so it must be a two sample t-test. And I told you the other hand, he says population variances are equal. It means here, pooled is gonna be yes. Okay, let's run the test together. So I'm gonna go to stat, tests, two sample t-test. Data, this time we're gonna select data. Okay, my data is in L1 and L2. Frequency is 1, 1, and we need to test that mu1 is not equal to mu2. If you have any questions, feel free to ask. Pooled is yes. And then we're gonna hit calculate. Okay, T is negative 0.117. P-value, look at the p-value, it's a huge, 0.9089. Well, it's bigger than alpha. And we fail to reject HO. So there is not sufficient evidence to support the claim at the 5% level of significance. Any questions, guys, about section 8.2? All right. So I'm gonna go and do something else right now, and then I'll come back. I'm gonna do some more practice since we managed to finish this. Okay. We're gonna do some practice exercises on 8.1 and 8.2, some more practice. So it's called chapter 8, review exercises. Okay, so we're gonna do question 1. Let's do this together. Dr. Smith would like to determine if there is a statistically significant difference between her 2 Math 1800 classes. To make this comparison, she will compare the results from exam 1. Class 1 had 33 students take the exam with a mean of 82.6 and a population standard deviation of 1.41. Class 2 had 31 students take the exam with a mean of 84 and a population standard deviation of 3.63. Can Dr. Smith conclude that there is a difference in the mean tested grades between 2 classes at alpha equals 5%? So let me grab a blank sheet of paper, guys, for this. And let's do this one. So we have class 1, 2 math classes. So class 1 and class 2. Let's see what the results. The first one, class 1 had 33 students. So N1 is 33. With a mean of 82.6. So guys, you agree with me that X1 bar is 82.6. Sometimes he won't give you the table and split them up just like I'm doing. So you have to do it, yourself. And population standard deviation, I think you should agree with me. This is sigma 1 is 1.41, not as sigma. He says population standard deviation. I hope that you get it by now. Class 2 had 31 students with a mean of 84 and a population standard deviation, sigma 2, 3.63. Alpha is 0.05. Can Dr. Smith conclude that there is a difference in the mean tested grades between the 2 classes at alpha equals 0.05? Okay, guys, can you tell me what the signs are going to be? So I'm just gonna put mu1 and mu2. This is my mu1 right here, and this is mu2 for class 2. So what would it be, guys, for the signs right here?
Equal or not equal to?
Exactly. And there is a difference, that's the claim. If the question, can Dr. Smith conclude that they are equal, then the claim would have been an HO, but he says difference. Difference, guys, means not equal. Please be aware of that. And since sigma 1 and sigma 2 are given, we have to use a 2-sample z-test. Even if you attempt, guys, to use a 2-sample t-test, it's gonna ask you for pooled. And then when it asks you for pooled, you don't have information whether the population variances are equal or not. It didn't say. So how are you going to answer this question? So then you know that you've made a mistake. You have to go to 2-sample z-test. So let's go to this and do it together. All right. So clear. Stat. I'm sure now you appreciate this calculator, worth the investment with this chapter now. 2-sample z-test. We don't have data, it's summary. So you go to stats. Okay. Sigma 1, 1.41. And sigma 2, guys, is 3.63. Please stop me at any time if you have any question. We have plenty of time. X1 bar, 82.6. N1 is 33. X2 bar, now I move to the other side. X2 bar is 84. And N2 is 31. And we're testing that the means are not equal in the alternative. Let's do a draw here. Okay. Z is negative 2.0096 and p-value is 0.0445. Let me write them down. So it's negative 2.01 and p-value is 0.0445. And let's compare the p-value with alpha. Oh, the first time p-value is less than alpha now. And how do you compare, guys? Look, this is how you compare. 0, 0, decimal, decimal, 0.0, 0.0, same thing. Now, a 4 is less than a 5. So you compare them digit by digit. Since 4 is less than 5, then the whole thing is less. So we reject HO. And we say, look at the conclusion this time. Instead of there is not, we've been putting there is not. Now we're going to put there is enough evidence. At the 5% level of significance, to support the claim. So we're saying we can support the claim that there is a difference and I'm not reinventing anything. I'm just copying this language, guys, right here in the mean test grades between the two classes. So that means the two classes are performing differently. But which one is better, we don't know. We didn't test that. We just tested that they are different, but we didn't test whether one is bigger than the other and one is smaller. That wasn't the question. So this is another review, guys, with the two sample Z test. Remember, sigma 1, sigma 2 are known. Known means given to you in the problem, and they were given here, sigma 1 and sigma 2. Let's go to the next exercise. Question 2. I want to try to focus on those two sections, so make sure that you master them very, very well. A survey found that the average hotel room in New Orleans is $88.50, and the average room rate in Phoenix is $84.75. Assume that the data were obtained from two samples of 55 hotels each, and that the population standard deviation were $5.60 and $4.83, respectively. At alpha equals 5%, can it be concluded that the average hotel room in New Orleans cost more than Phoenix? Okay, so let's do this. Question 2. So we have in New Orleans first and Phoenix next. This is going to be labeled mu1 and that will be labeled mu2. All right. Let's put in some data here, what he gave us. He says 55 hotels each. So guys, do you agree that it's N1 is 55 and N2 is 55 as well? X1 bar, he gave it to us at the beginning. It says 88.50. And X2 bar, it's 84.75. And he says population standard deviation. Look, I put that between parentheses, guys, so you know it is population standard deviation. So it's sigma 1, 560, and sigma 2, 483. And what is alpha? 0.01. Okay, now you have to help me, guys, and tell me which hypotheses we're testing. I'll state them. Okay. Can it be concluded that the average hotel room in New Orleans costs more than in Phoenix? So can you guys tell me what the signs are?
Less than or equal to and greater.
So HO is greater than or equal to, or no? We need to check that New Orleans costs more than Phoenix. This is in New Orleans and this is Phoenix. So what would be the sign here?
Greater than.
Yep. And then the other one will be less than or equal to. Exactly. You see, I had the impression that some students think always that they have to put something in the null hypothesis. No, if he gives you the claim and it turns out to be in the alternative, start with the alternative first, and whatever left over for the null, just put it in the null. If he says test the claim that both in New Orleans and Phoenix are the same, so you start with equal here, and then you put not equal there. So you don't have, to start writing HO first. You can do HA and then go back to HO. Okay, guys, you agree with me because sigma 1 and sigma 2 are known. We use two samples Z test. Okay, let's do it. So turn the calculator on. And stat, tests, two sample Z test, not data, sigma 1. Okay, 560, sigma 2, 483, X1 bar was 88.5, N1, I think they're 55 each. X2 bar cost 84.75. N2, guys, is 55. And we need to test that in New Orleans cost more than Phoenix. So that's the one. I'll let you glance at the screen before I hit calculate. All right. So let's see if we're going to be able to support the claim. Okay. Z is 3.76. I'll write it down. And look at the p-value. I'm just going to copy it as is and interpret for you guys. It's 8.476 E negative 5. Please don't ignore the E. The E negative 5 means you have to move the decimal place 5 digits to the left. So actually this one, guys, is if you move this 5 digits to the left, it's going to be, it's almost 0. So if you are asked to round, to 3 decimal places, it will be 0. Again, once you see E negative 5, guys, take a note. You reject HO because the p-value is going to be very small. So p-value is less than alpha. Reject HO. And since we reject HO, we start with there is. Enough evidence at, in the book, sometimes online, he says there is sufficient evidence. Sufficient or enough evidence, guys, would mean pretty much the same thing. So there is enough evidence at the 0.05 level of significance to what, guys? The claim is in HA. What's the magic word?
Support.
Support, yes. You only use the word reject if the claim was in HO to support the claim. I hope that with so many exercises we're doing, guys, you're not finding it too difficult to grasp because it is a continuation of the previous chapter. Okay. So that's a question 2. Now we're going to go to question 3. Question 3 is a practice of section 8.2. Let's do it together. So question 3. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the values of homes. A random sample of the two groups appraised 10 homes. So we have tax assessors first. And we have real estate appraisal. Okay, we'll label those probably as mu1. This is going to be our mu2. So each one surveyed, assessed 10 homes. So N1 is 10, N2 is 10. Is there a significant difference in the values of homes for each group? Let alpha equals 5%. Assume that the data are from a normally distributed population and that the population variances are not equal. He says population variances are not equal. That's a hint to you guys that you have to use a 2-sample t-test because pooled is going to be no. Pooled, no. All right. So I got X1 bar, $83,000, 256. I got S1. You see, guys, he gives you S1, so stay away from Z. But once he gives you S, X2 bar is 88,354, and S2 is 2,341. And what is alpha? Alpha is 0.05. Okay, guys, can you help me and tell me what the null and the alternative are? Is there a significant difference in the values of the homes of each group? So what do you guys think? What are the signs?
Equal and not equal to.
That is correct. And where is the claim?
In the HA.
Yep. And if you ask me why, he says, is there a difference? Difference means in HA. If he say, are they the same? Then the claim would have been in HO. In real life, guys, most of the claims will turn out to be in HA. If you want to rally support for your claim, it has to be put in HA. we always try to work against the null hypothesis. Okay, I think you agree with me, guys. It's a 2-sample t-test. And let's perform the test. So you go to stat, tests, and then you pick 2-sample t-test. Let's do it. X1 bar. He says 83,256. S1, he says 3,256. N1 is 10. X2 bar, I got 88,354. And S2, I got 2,341. And N2 is 10. We're testing that they are different. And pooled, we says no, because it says population variances are not equal. And now you're ready, guys, to hit calculate. There you go. Calculate. And T is negative 4.02. And look at the p-value, guys. There's an E minus 4. Please do not ignore it. It means it's almost 0. So I'm going to copy and paste him here. T is negative 4.020. And p-value of the calculator is this. And let me interpret this to you guys. It means move this 4 digits, so it's going to be 0.00095. Okay. What about if you were doing my math lab and ask you to round the p-value to 3 decimal places? What would be the answer?
0.001.
Exactly. I wanted to do that because you are asked to round to 3 decimals. Because you go to 3rd digit, then you look at the next one, it's 9, then you must add up 1 here. So you just add 1 and drop the rest, which is, guys, less than alpha, for sure. You can close your eyes and reject the null hypothesis when you see the E on the calculator. It won't be an E positive, it's always an E negative. So reject the null hypothesis. Okay. We reject the null hypothesis, and the claim is in the alternative. We support the claim. There is enough evidence. At the 0.05 level of significance to support the claim that, there you go. The claim that there is a difference in the values of the homes of each group. There is. A difference of the value of homes in each group. We are saying that they do assess differently. That's what we're saying, which is very important information to know. So this is question 3, and I think we have one more, guys, that covers section 8.2. Which is, we're going to do question 4 right now. A researcher suggests that male nurses earn more than female nurses. So they're claiming that male nurses earn more than female nurses. A survey of 14 male nurses and 14, right here. And how many male nurses? A survey of 14 male nurses, sorry, the 14 should be here, and 22 female nurses report these data. Is there enough evidence to support the claim that male nurses earn more than female nurses? Use alpha equals 5%, assume that the data are from normally distributed population and that population variances are not equal. So population variances are not equal. Here's the hint for you guys. Pooled is no. All right. This is a little bit of a tricky question when it comes to stating the null and the alternative hypothesis. He labeled the females as 1 and he labels the males as 2, but he starts talking about male nurses. Remember that. So I'm gonna put the 2 statement, guys, and I'd like you to tell me what do you think the null and the alternative are. So we wanted to check if male nurses earn more than female nurses. What would be your null and alternative hypothesis, guys?
The alternative would be greater than?
Okay.
Alternative is less than because the alternative 1 is for the females.
Exactly. Look, I know why you say more than, because you saw the word more than, but remember, he switched the labels here. The mu1 is for females. Look, females, he call it 1, and males, he call it 2. So if you keep greater than, then you are testing that females make more than males. That's not what he wants. It's just in this question, guys, I switched, I swapped the numbers to show you that you have to be very careful when you read it. We want to test that males make more than females. But if I say I'm older than you, if you want to say the statement again, you can say that you are younger than me. It's the same statement, but it depends of who start first. If I start with the females here, I have to check that females earn less than males. So if males earn more than females, it means that females earn less than males. So it would be mu1 less than mu2. And this is a greater than or equal to. Again, we are still testing the same claim that females earn less than males. I could have, guys, reworded this problem. I said, is there enough evidence to show that females earn less than males? It will be exactly the same problem. Okay, so it's going to be a 2-sample t-test. The hint, guys, he gives you S1 and S2, so you can't use Z. It has to be S. And let's do it. So I hope that you feel we've done enough with those. I want to make sure that you have a good grasp of those 2 sections first before we go to the next one. Okay, stats. So X1 bar, 23,750. I think nurses make a lot more than that. So if you're pursuing this field, guys, don't be discouraged by this exercise. It's just, we made it up. N1 is 22. X2 bar, sorry. X2 bar is 23,900. S2 is 300. N2 is 14. And we're testing that females make less than males. So mu1 less than mu2. And pooled, we decided it's a no. There you go. So T is negative 1.558. And the p-value is 0.0661. This is female, and this is male. So T is negative 1.556, and p-value, guys, is 0.0661. All right, that's all I need. And alpha is 5%, so this is bigger than alpha. Fail to reject HO. And if you fail to reject HO, you start, guys, with there is not. Not enough evidence at the 5% level of significance to support the claim that male nurses earn more money than female nurses. Maybe you'll ask me, how come we haven't made a statement that there is enough evidence to reject the claim or not reject the claim? Because none of the claims that I did in this handout today turned out to be in the null hypothesis. All of them turned out to be in the alternative hypothesis, and that's why we had to use the language of support. Okay, the last thing, guys, that we're gonna do before we wrap this up, just one sec. So section 8.4 deals about testing the difference between two population proportion, P1 and P2. P1 is the proportion from population 1, and P2 is the proportion for population 2. What you did in chapter 7, you just tested one proportion, P, but since we have two of them, we have to label them as 1 and 2. And can you guys guess what would be the three scenarios for the null and the alternative hypothesis? What would you put here and there? First scenario. Equal, not equal. Just to show you it's going to work the same way as means. Here's a second scenario, and here's the third scenario, guys. You just choose one of them. So again, just same thing as in sections 8.1 and 8.2. When you test the difference between two proportions, you're gonna even have to select P1 equals P2, P1 not equal P2, P1 is greater than or equal to P2, P1 is less than P2, and P1 is less than or equal to P2, and P1 is greater than P2. You just choose one of them. The conditions of the test. The samples must be randomly selected. The samples must be independent. And we have to verify that the sample size N1 with the proportion from the first sample is greater than 5 when you multiply it. Q1 is the complement of P1. So if P1 is 70%, Q1 will be 3%. If he doesn't ask you to verify the requirement of the test, you just don't verify him. You just go and perform the test. And to perform the test, guys, these are the 5 steps. State the null and the alternative hypothesis. Calculate the standardized test statistic Z. Find the p-value P. Make a decision to reject or fail to reject the null hypothesis, whether p-value is less than alpha or p-value greater than alpha, and interpret the decision in the context of the original claim. I'm not gonna do an exercise now, but just to show you guys that what's coming ahead is no different, from what we have done so far. So next time I meet with you, I will work out this section that should take me only about 15 minutes and probably another half an hour or 40 minutes to do section 8.3. and then we can do plenty of practice exercises. And actually on Monday, I'm gonna try something new with you. I'm gonna put you in breakout rooms, give you an exercise to each group and have you work on it in breakout rooms in Zoom. So we're gonna try this out next time.